Hi, so in the last video we looked at how to get the intrinsic gain of the transistor by putting a current source here, which meant the gain became the transconductance times infinity in parallel with GRO. So this time around we are going to look at how to replace this current source with a properly designed current source, because there's no such thing as an ideal current source. We're going to design this current source, and from the previous video we know a current source that takes current from a VCC into a node should be a p-type current source. We are going to first study how to play around with a p-type transistor. So we are going to use a PNP device here, a PNP device. Okay, so then we choose a particular device here. So the particular device here is a 2N2909, which is also pretty much common. It has the same reverse saturation of 10 raised to the power negative 14, just like the 2N2222 transistor. Okay, so we are just going to okay, so pretty much I'm going to copy this circuit here right here. So to copy, just press Ctrl C and you drag along the area you want to copy, and I'll delete this. Okay, so that's the same circuit we built in the previous video, just I need to change this device here into a transistor, but a PNP transistor. So I look for PNP, I just type PNP right here and place, and I have that. Okay, then I right click and choose the 2N2907 transistor. Okay, so what I'm going to do is that we are going to put you don't need to test for the intrinsic gain of this transistor. We are going to just put in the how do you call it, a resistor. Okay, so let me put something quite reasonable here, 5 volts and 1K resistor as we have been doing previously. Okay, so the condition is that for the transistor to operate as an amplifier, the base collector junction should be reverse bias and the base emitter junction should be forward bias. So assuming there's a lot of things wrong with the circuit, but when we do this and we run, what are we going to get? Because this is what we'd have done for the NPN. Any of them works, and I want to see the voltage here at the output. Okay, all right, so what actually is happening here? We have to look out. So this is ground and this is that, so NPNP, so this shouldn't be forward bias. So in that case, what are we getting again? Okay, no, we didn't expect to get anything reasonable. Okay, we can't tell. Yes, so the actual gain after taking out the DC bias voltage, see, we are getting no gain. This again, so we are getting absolutely no gain from the transistor. That's because we are doing a lot of things wrong. Okay, so now let's try and fix it. So first of all, we know for the PNP transistor, current should flow from the emitter to the collector, not from the collector to the emitter. So current cannot flow from the ground to a node. So first, to fix this up, we need to turn it around. So let me just click on M to move this device. then I press Control R and Control E to do the mirror inversion. Okay, and so let's run this and see. Okay, so it's still not fixed, so let's do the troubleshooting and understand why it's not fixed. So if I look at the current here, okay, node voltage. So the node voltage here is 1.13, and this should be somewhere 680 millivolts. But so okay, let's do the right thing. So the right thing to do is we want this base emitter junction, the difference between the base and the emitter, to be 5 volt, 0.7 or 0.68. As it stands, the base to the emitter, so the base voltage to ground is 680 millivolts, and the collector, the emitter voltage is tied around 5 because of this. So this guy here, okay, so this is the emitter, and we want to remove this because we want to pick it up from the, so let's write this up. So that was acting as like an emitter degenerator, so it's trying to stabilize things for us. But you know, we are used to getting the resistor in the collector, so that's another issue we had to fix. So I'll put this here and delete this wire and make it clean. Okay, so the collector goes to ground. Let me just fix this wire here. I'm not sure that was grounded, but to be safe, let me just put another ground here, and I can just delete this, and I'm sure everything is grounded. Okay, so let's make this 1K. So that resistor here was acting as a degenerating resistor to the transistor. So now there's no degeneration. I'm going to run it and see the output properly. So and now this shouldn't be here anyway, so I'll just delete this up and pick it at the collector node and run. Okay, we are still not getting any voltage gain at the output. So why are we not getting any voltage gain? So basically it's because the base emitter junction, the difference between the base and the emitter, is not what we expect. We want the difference between there, because the emitter is operating at a voltage of 5 volts and the base is operating at a voltage of 680 millivolts. So we want the device to be forward bias by forward active. So the base emitter junction, in this case we call the emitter base junction, the difference between them should be the 0.68. so if I have to raise this up to 4.32, and I run, finally there is gain and it's acting like a proper circuit. So why is it acting like a proper circuit now? Because now the base, which is N type, is more negative than the emitter, which is P type. So the emitter is more positive, and the difference between them is the 0.68, and we have a current of 2.57 milliamperes flowing through them. So at least we have an idea on how to use the PNP as a common emitter stage for an amplifier, and that giving us a bit of comfortability or familiarity with the PNP device. In the next video, we will look at how to build a proper current source with PNP device, replace this idle current source, and see how it goes. So until then, goodbye. Thank you for your time.